So let's look very briefly on the Gauss-Jordan method for solving systems of linear equations. In operations research, how this is a very brief topic overall. But it's covered, generally speaking, as an overview because Gauss-Jordan method is looked at several, for some review exercises and such. Because of the row reduction thing, the idea of row reduction when you're solving a linear system of equations or in any other process that involves it. Well, it's used in other algorithms, especially the simplex algorithm uses row reduction as one of its main properties. It's one of the main things you do when you actually employ the algorithm. Is you mess around with row. You do operations on the rows with each other. It's a very similar process. There's similarities at the very minimum. But yeah, the notes are in linear algebra, so over here we're just going to look at these problems real quick. So here's a 4-variable system of equation. You write it like as you do. You write it in the augmented matrix format. We do row 3 minus row 1. So we get 1, 0, 0 for the first column. And we also get a column full of them. So then we do row 3 minus row 2, and then we get a row full of zeros, except for 1 at the right hand side. So this means there's no solution as 0 does not equal 1, you can also say, basically, because you have all zeros and you have 1. And there's no way to, this is basically the end point for the Gauss-Jordan algorithm. We have no solution. This one, let's look at this one. You set it up as an augmented matrix. And you do row 2 minus row 1 and row 3 minus row 1. And we get some zeros. We get 1 0 from that, but we're just trying to simplify it down. We found it already. Then we can do row 3 minus 2 times row 1. No, row 3 minus 2 times row 2, and row 1 minus row 2. And that'll give us zeros and 1s on the left-hand side only. Then we can do row 3 minus row 1, and we just get 0, 0, 0 on the bottom. 0, 1, negative 1 on top row, and middle row 1, 0, 2. So we swap the middle and top row. Row 1 will do. And we get it in a Gauss-Jordan method format. So this is one solution. It's an exact unique solution, even though we have zeros at the bottom. And it's basically because there's only 2 variables, so there's no real parameters. We got a solution to both variables, so there's no parameters. So I think this is a good one to look at like that. There are cases where you can have a row of zeros, but you still have an exact solution. But in general, usually you'd have infinite solutions, but we don't here. We have x1 equal 2 and x2 equal negative 1, because it's 1, 0, 2, so x1 equals 2, and 0, 1, negative 1, so x2 equals negative 1. There's only 2 variables. It's a unique solution, and it's a point at that. It's a point solution. And finally, this is another one. Right, there's a matrix, and it's a lot of zeros already. But we do row 4 minus 2 times row 3, and that'll get it so we have a row full of zeros and a 1 at the end. And like the first problem, it's no solution as 0 does not equal 1. But yeah, no solution again for this one. And that's just a few exercises in this idea.